All right, everyone, today we're going to explore complex fractions, meaning a fraction within a fraction. So let's take a look. What is a complex fraction? A complex fraction is when you have a fraction within a fraction. So let's take a look at these examples. I'm going to show a longer division line. I might have a constant or one term divided by a fraction. I might have an expression divided by a complex fraction, and I might have a fraction being divided by a complex fraction. So here's all the instances. Now, you've dealt with fractions within fractions before, so let's quickly review how to deal with that. So when we think back to simplifying them, you've actually done this all the way back to elementary school. The first thing I recommend now, though, just to stay organized, is when you have a fraction within a fraction, I recommend rewriting it as a division symbol first, just to help us visualize the information. And then we know that we don't deal with dividing, we multiply by the reciprocal of that second fraction. Then we can deal with the properties of multiplying numerators and denominators. So let's look at some examples that are up to our level to see what we need to do. So to start off here, I can see that I have a fraction within a fraction. The first thing I'm going to do on here is I'm going to rewrite it with a division symbol. Now, as I'm doing this, some of you might think, well, why not just multiply by the reciprocal right away? I'm okay if you jump to that step, okay? So if you want to skip and go straight here, 6x plus 9 over 5x times 10 over 2x plus 3, you can do that. Next, I'm most likely going to need to factor on it almost every problem. So here I can see that I have a GCF, so I'm going to divide out a 3, which gets me to 2x plus 3. But it looks like the rest is pretty much all factored out, and we multiply fractions straight across, so I'm going to bring that 10 down, 5x, and this expression of 2x plus 3. So now I can see what cancels. I've got 2x plus 3, 2x plus 3. 10 over 5 reduces down to 2 over 1. So that leaves me with a 3 times a 2 over a 1 times an x. So if we were to simplify that all the way, I'd have a 6 over x as my final simplified fraction. Let's amp it up a little bit. So here I have a pretty basic numerator, but my denominator has 3 separate terms. I can't deal with any multiplying by the reciprocal until I take care of these terms. I need 3 terms to become one fraction. So I'm going to deal with this whole denominator in light blue here. So I'm going to put it as 1 over 1 plus, I'm going to leave some space, over x plus 6 over x squared. As I look at that, I'm adding fractions, so I need a common denominator, which in this case would be x squared. So I need to multiply each fraction by what it needs for an LCD. So the first fraction is timed by x squared. The second fraction is timed by x. And the third fraction already has an x squared. So this leaves me with x squared plus a 5x plus a 6 all over my common denominator of x squared. Now this I can deal with, so I'm going to rewrite this. I currently have an x plus 2 now over my new denominator of x squared plus 5x plus 6 all over x squared. So now I can deal with multiplying by the reciprocal. So my numerator of x plus 2 over 1, and I'm going to times it by the reciprocal of my denominator. That's the part that was new. So now when I look at this, we've already done adding, subtracting, multiplying, and dividing complex fractions. So I just need to see if anything cancels. So let's factor this denominator here. I know I'm going to have x and x. Looks like 3 and 2 positive would be factored down. So that means I've got an x plus 2 and a term of x plus, or excuse me, a factor of x plus 2 on the top and bottom. Let's see, that leaves me with an x squared on top and an x plus 3 on bottom, and that does not reduce any further. So that would be my simplified complex fraction. Okay, here we go again. I have a numerator that is not one fraction. So I need to deal with just this first. So off to the side, I'm going to write an x over 1 minus 16 over x. I'm adding or subtracting fractions, so I need a common denominator, which is going to be x. So that means my first fraction needs to be multiplied by x. This gets me to an x squared over x, and then a minus 16 over that same common denominator. So if I rewrite my original problem, I have an x squared minus 16 over x, and it's being divided by this trinomial of x squared plus 8x plus 16. So if I get into the work of this now, instead of dividing by a fraction, I'm going to multiply by the reciprocal. X squared minus 16 over x times 1 over x squared plus 8x plus 16. So remember, even if it's just this trinomial, it's still over 1. Okay, I still have to use reciprocal. But as you can see, I've got some major factoring going on here. So this first, if I multiply straight across, x squared minus 16 is difference of squares. I could put times 1, but it's not going to change anything. Then I have an x and a trinomial that'll break down to a 4 and a 4. So let's see what'll cancel. X plus 4, it's got to be 1 to 1. I know there's 3 of them. You can't cross off all 3, only 1 to 1. Let's see what that leaves me with. I now have, it looks like, an x minus 4 over an x and an x plus 4. That does not cancel anymore because if I was to rewrite this, I'll accept either or, but if you feel a little better, if you were to distribute this, definitely nothing would cancel there. Remember, you can only cancel factors, not terms. So that would be my simplified fraction. All right, let's really start to have some fun here. Okay, I have some crazy numerators and denominators, so I need to deal with them separately. I'm going to deal with this numerator in blue and this denominator in green. So let's start with the numerator. I currently have an x over 1, whoops, sorry about that, plus a 4 over 1 minus a 1 over x plus 4. I have 3 terms, and I have an LCD of x plus 4. So I need to multiply this first fraction by x plus 4, and this second fraction also by x plus 4. So if I look here, I need to distribute this x. That gets me to x squared plus 4x. Okay, I'm going to try to underline here. So this becomes this. Then I have to distribute this 4. So that becomes positive 4x plus 16. And then I'm subtracting this 1, which already has an x plus 4 as a denominator, so I don't need to worry about that. All over that LCD. So in the numerator, I need to simplify, combine like terms, end up with this pretty nice trinomial quadratic in the numerator. Okay, so if I'm going to rewrite this big fraction, I currently have my new numerator of x squared plus 8x plus 15 all over x plus 4. All right, let's deal with that crazy denominator. I have an x over 1 plus an 11 over 1 plus a 48 over x minus 3, which means my LCD is going to be x minus 3. So take this first one times x minus 3, second one times x minus 3, and the third term already has an x minus 3. So again, I need to distribute, which gets me to a value of x squared minus 3x plus I need to distribute that 11, which gets me to 11x minus 33. And I've got a plus 48. It already has that LCD of x minus 3. Let's combine like terms. I have an x squared. I have a, let's see, what have we got? Plus 8x. And let's see, I got a plus 15 there, all over an x minus 3. How does that look? Okay, so if I bring that over to the original question, look what's happening here. As I take a look at this, if I multiply by the reciprocal, so numerator times reciprocal denominator, I don't even need to factor, you guys. Look what happens here. The whole trinomial is the same as the whole trinomial, which means that all cancels, and I'm left with this simple factor of x minus 3 over an x plus 4. Okay, so all that work to simplify that down. Now this is a fraction that I can deal with, that I can graph, that I can isolate key features for. All right, so I know that was a lot of writing, and as always, one of my recommendations is it's hard to gather all the information and write at the same time. So maybe take a moment to re-watch one of the examples, okay? That can make a big difference by not being distracted while you just listen and watch, okay? This is pretty systematic in the sense that we've got these steps, but there's a lot of steps, and I don't want you to get confused in between each step, okay? Make sure, as always, that you check Google Classroom, see what else is coming up next, what are we going to be working on, and then as always, if you have any questions, make sure you see me. Until next time, have a good one.